So El Nino and the flip side, La Nina, is collectively known as ENSO, or the El Nino Southern Oscillation. And it's this coupled phenomena between the atmosphere and ocean. So what that means is the atmosphere and ocean are talking to each other and influencing the weather around the globe. And it's one of the biggest influences of weather patterns globally, the ocean and the atmosphere. So during El Nino, there's typically warmer ocean temperatures over near South America and cooler ocean temperatures near Australia. And what this does is it weakens the winds that move from east to west across the equator. And this weakening of the winds sort of pushes this region of lots of rainfall and convection that's typically near Australia out towards the middle of the Pacific. And that's why in Australia, El Nino is typically associated with warmer than average and drier than average weather conditions. Places in Asia also typically get hotter weather, as we've seen in the last few months, with strong heat waves over Asia. The funny thing about El Nino is that it was actually discovered by Peruvian fishermen hundreds of years ago, because they noticed that the warm ocean temperatures of the coast of South America was impacting their fishing. And so because there's less cold upwelling from the deep ocean and less nutrients rising to the surface, they actually would catch fewer fish. So it can have far-ranging impacts, not just on the weather, but on aquaculture as well. So scientists use what we call subseasonal to seasonal forecast models to try and predict El Nino events. And so these models are really looking at this time period from 2 weeks to 9 months, which is quite a murky area. It's very difficult to forecast that far in advance because the atmosphere is what we call very chaotic. And we can't really forecast the atmosphere that far in advance, but we can have an idea about what the ocean's doing that far in advance. So that's why there's a lot of emphasis on the sea surface temperatures and what we call this Nino 3.4 region. So that's a box over in the Middle Pacific where scientists look at whether the ocean temperatures are above or below average. And once they're above about 0.5 degrees, if you're the US, NOAA, or if they're about 0.8, if you're the Bureau, that's when they consider this to be an El Nino. So climate change is impacting the baseline. So when we just define an El Nino, we're looking at temperature anomalies. So because the ocean is hotter generally, in order to get a 0.5 temperature anomaly, we actually need more heat than we previously did. And so there's a lot of debate going on about whether we need to redefine our El Nino definitions to take into account climate change.